let's loop through lists together, open up a new Colab notebook, or continue with the one you are already working on. And let's go ahead and get a nice list of prime numbers. How about all the primes less than 20? Can you do it? Do it with me. I'm impressed if you can do it quickly. Just think prime numbers are all numbers that are only divisible by themselves and 1. They have no other numbers that divide into them. Okay, so there's a list of all the primes less than 20. Go ahead and press Shift-Enter to store that list. And now let's go ahead and loop through it. Now, how do we first set up the loop? Well, we started the loop with 4, and then we use our variable. We can pick what we want here. Like you could pick I, you could pick P, short for prime. You could pick prime singular. Any of those are fine. I sometimes like to do prime singular here. So for prime singular in the list of primes plural, and then I need my colon. Now, what am I going to do with it? Well, I don't know. We could do some different things. We could just square it. Okay, that's interesting. But if we just do that, it's just going to disappear. So why don't we show the squares, right? Let's print out the squares of all those primes. Okay, so I'm going to press Shift-Enter, and you can see we have looped through all of these primes, and we can see their squares underneath. Okay, so what's something that's a little more interesting that we might do here? Okay, first of all, the printing out is sort of interesting for display, but you might want to save it into another list. So to show you how you can modify this code to actually save it into a list, what you would do is start off with a blank list, like square primes. Okay, so that's what we're going to square the primes. And then we go ahead and we set up our for loop. So I'll change it this time, like it's totally fine. I'll say in this case, I'll use I for I in primes. And now what I want to do, instead of printing it out, I want to append it to the new list. So I'm going to hit square primes dot append. It's I squared, right? Because you've got to square it. And so what that's going to do, see, this is going to loop through the list of primes. I've called them each I, but now I'm adding to my empty list, square primes, the square of each of these. And so we can verify that at the end by printing out, outside of the for loop, indexed all the way to the left, square primes. So get that set up. And so now we're looping through a list, but we're storing it as a new list. This would be probably a little more common. Press Shift-Enter to run the code. And now we can see we have those squares neatly grouped together in one list. Okay, let's take this one step further. So let's make a list of Mersenne primes. Okay, so this is a little bit interesting. And so what is a Mersenne prime? Well, it's primes of 2 to the p minus 1, where p is a prime number. Okay, and so these were postulated by Mersenne to be prime numbers. It was later shown that these are not all prime numbers, but it's actually a really great way to find huge primes. The big prime that was recently found in 2024, the largest prime known in the world today, and they often are, is a Mersenne prime. So how would we do this? Well, we can start with an empty list, call it Mersenne primes. Okay, so go ahead and do that. Now what's next? Well, we have a list of primes, so we can go ahead and loop through it just like before. And I'll keep with the syntax and use the letter P here. So for P and primes. And now what do I want to do? Well, the code that I want is in effect 2 to the P minus 1. Okay? And what do I do with that code? Well, I'm going to put it inside of the Mersenne primes list that I just created. And so I type in Mersenne primes, and I put in this 2 to the p minus 1. To put it in, by the way, it's not a function. You need to append it, okay, because it's a list. And when you add an element to a list as you append it. Now, we want to check it just like we did before, so we can certainly print out the Mersenne primes. And let's just go over this code briefly. So for suggests, we're starting a for loop. Now, p is our choice of a variable. It's the letter short for primes. You could pick anything you want here. And the point here is this for loop is going to be inside of a previous list that has been defined, which is primes. Okay, that list is up here at the top of the notebook. And Once you hit the colon, that suggests you've completed the line with the for loop. Now we need the computer instructions of what we're going to do with each element in the list. What are we going to do with the letter P? Well, we're going to raise 2 to that power and subtract 1 because that is how Mersenne was able to generate a lot of primes. And we're going to store those values in our empty list called Mersenne primes. And do note that because this line of code is tabbed inside of the for loop, it is going to add that for each element in the list. That's the whole point of the for loop. Anytime you're inside of the for loop and you use this variable, it's going to do it that many times. Okay? And then we're going to verify the list of Mersenne primes. Okay, so this is sort of interesting. Let's press Shift-Enter to run the code. And look at how quickly, look how big these get, right? Like these first 3 are definitely prime. I think 127 is prime, and beyond that, I'm not sure. Okay, I can tell you that all Mersenne primes are not prime, and so they're called Mersenne primes though because Mersenne thought they were, and obviously because these get so big so quickly, it can be very difficult to check, the prime factorization of these very large numbers, especially when you're at Mersenne's time, which was an age before calculators, right? So imagine trying to search if there are any primes that go into, say, that large number there. And so there is a nice group of Mersenne primes, and this is what you do to loop through lists in Python.